A flywheel rotates on a fixed axle in a steam engine. So flywheel is a rotating machine used to store energy. Okay. The flywheel is rotating at a rate of 600 rpm before a brake begins decelerating the flywheel at a constant rate of 30 radians per second square. So decelerating means negative acceleration. So that it means the flywheel is slowing down. Here flywheel is slowing down at a constant rate, 30 radians per second square. What is the time required to bring the flywheel to a complete stop? How many rotations does the flywheel go through while decelerating? In this question, first given initial speed of flywheel. Initial speed how much? Ni is equal to 600 rpm. rpm means revolutions per minute. Next given constant deceleration. Constant deceleration. Okay, deceleration means negative acceleration, slowing down. Here flywheel is slowing down. So constant deceleration alpha is equal to deceleration represented with negative sign 30 because it is slowing down, minus 30 radians per second square. Okay. So here we have to find time required to bring the flywheel to a complete stop. So this is a linear speed. We need angular speed. So angular velocity, let us say angular velocity omega I is equals to, angular velocity omega I is equals to 2 pi n by 60. 2 pi n by 60, 2 pi ni by 60. So 2 pi ni. Initial angular velocity 2 pi into ni how much? 600 by 60. 60 ones, 60 tens. Okay. So you will get 20 pi radians per second. Radians per second. Okay, now this is angular velocity of flywheel, initial angular velocity. Now a constant deceleration is applied. Alpha is equal to minus 30 radians per second square. So first question, we have to find time required. Time required to stop the flywheel. Time required to stop that flywheel. Okay, no? So here flywheel comes to the rest. So at rest, angular velocity omega f, final velocity, let us say omega f is equal to, final angular velocity of flywheel is 0. It comes to the rest. Flywheel rest loki vachestundu. So omega f is equal to 0. Okay, no? So final condition of final position of flywheel is rest. So omega f equal to 0. And omega I we got how much? 20 pi. Okay, and alpha is also given, alpha equal to minus 30 radians per second square. We need time. Okay, t. So since here given constant deceleration, we can use equations of rotational kinematics. So what is that equation? So we have initial angular velocity, final angular velocity, alpha and t. So what is the equation to find time? So omega f is equals to, in equations of motion, omega f is equal to omega I plus alpha t. Okay, so from equations of motion, so from rotational equations, omega f equal to omega I plus alpha t. Omega f 0, omega I 20 pi plus alpha minus 30 into t. Now transpose minus 30t. Negative t becomes positive t. Positive 30t. 30t is equal to 20 pi. Now t is equal to 20 pi by 30. That okay, now 0 0 get cancelled. 2 pi by 3. So 2 into pi value approximately 3.14 approximate value by 3. So 2 into 3.14, 6.28 by 3. So if you calculate t is equal to approximately t value, time required to stop the flywheel, approximately equal to 2.094 seconds. Okay, this is first question answer. So time required to bring flywheel to a complete stop is 2.094 seconds. Okay, so next we need number of rotations does the flywheel go through while decelerating. Okay, so number of rotations we have to find. Next we have to find number of rotations. Number of rotations. Okay, number of rotations. Number of rotations. So first we need theta. So number of rotations we have to find theta. Okay, so how to find theta? So again we have a relation in equations of motion. Omega f square minus omega I square is equal to 2a delta theta. Okay, so not 2a, 2 alpha delta theta. Okay, because your object is making rotations, revolutions. 2 alpha delta theta. So omega f final angular velocity, omega I initial angular velocity, alpha acceleration or deceleration, next delta t change in angle. Okay, no, angle in radians, angle in radians. Okay, we need delta theta. Delta theta is equal to omega f square minus omega I square by 2 alpha. Let us substitute all values. Omega f 0, final angular velocity 0, initial angular velocity 20 pi whole square by 2 into angular acceleration minus 30. 0 square 0 minus 20 pi whole square means 400, 20 square 400 pi square by minus 60. So minus 400 pi square by minus 60. So minus by minus plus 400 pi square by 60. 1 0 get cancelled. 40 pi square by 6. 2 3s are and 2 20s are. So 20 into pi square by 3. So 20 by pi means how much? 20 by 3. 20 by 3 means approximately 6.67. Okay, no? Into pi square means 3.14 whole square. Okay, if you multiply you will get around 6.67 and 3.14 whole square, 65.76 radians. Okay, this is delta theta. Okay, no? Change in angle. So here we need number of rotations, but here we need number of rotations. Number of rotations. Number of rotations made by flywheel while decelerating. So number of rotations, n is equal, let us say n for number of rotations. N is equals to 65.76. We know that 1 radian is equals to 1 by 2 pi revolutions. 1 by 2 pi revolutions. 1 radian is equals to 1 by 2 pi revolutions. Okay, so 65.76 radians, 65.76 into 1 by 2 pi revolutions. 65.76 by 2 pi revolutions. Okay, so if you divide you will get around n is equals to approximately 10.5 revolutions. Approximate value 10.5 revolutions. Okay, this is the final answer.